Chapter 7, Section 1 is about ratios and similar polygons. So by the end of this lesson, you should be able to identify if polygons are similar and apply those properties to solve some problems. So the difference between similar and congruent is congruent means exactly the same. So same size, same shape, this is the same fire truck, just rotated a little. Similar means they're the same shape, but not necessarily the same size. So you can see that these are the same fire trucks, but this one's like enlarged. So you can think of similar as if you go to a copy machine and hit enlarge or reduce, you're getting the same image, it's just a different shape or a different size. Similar's symbol is just the squiggly that we usually have on top of the equal sign for congruent. So the definition of a similar polygon says that two polygons are similar if and only if their corresponding angles are congruent. So remember that means same measure. And their corresponding side lengths are proportional. So that's why we talked about ratios and proportions. We need to line them up. And if you take a look at each of these side lengths, AB corresponds to EF. This got twice as big. BC corresponds to FG, and again, it got twice as big. 4 gives you 8, 5 gives you 10. So we can see that when we divide these, they put the small one on top and then the big one on bottom. You get the same proportion, or the same ratio every single time. So let's prove if some things are similar. So first, identify the pair of corresponding sides and the congruent angles. So our angles, first ones are pretty easy. Angle M is exactly the same as angle Q because they're both right angles. And then it tells us that angle P and angle R are both 63. Remember, that means the third angle theorem determines what these last two angles are. So they have to be congruent. Angle M has to be the same as angle T by the third angle theorem. And if you did that, you would get that they were both 27 degrees. So we have the first condition down. Our congruent angles match up with all the angles in this triangle. So the next thing we have to do is we have to talk about the corresponding sides. So that means MN has to match up with QT, and NP has to match up with QR, and then PM divided by RT should give us the same thing. So MN is 2, divided by QT is 1, simplifies to 2. NP is 1, and QR is 0.5. And again, if you divide those, you get 2. PM is 2.2, and RT is 1.1, and we get 2. So because these are proportional, that means that these two triangles have to be similar. So a similarity ratio is the ratio of the lengths of the corresponding sides of two similar polygons. Now a similarity ratio matters which one you talk about first. So if I talk about the ratio of ABC to DEF, it's 3 over 6, 3 over 6, 3 over 6, or we can reduce that to 1/2. But if I go the other way around and talk about the ratio of DEF to ABC, it's 6 over 3, 6 over 3, 6 over 3, or 2 over 1, or we can just write that as 2. So pay attention to which one they're talking about first. So these examples, we're going to tell if these shapes they give us are similar. So determine whether these polygons are similar. If so, write the similarity ratio and a similarity statement, which is just like our congruent statements that we've written before. So they tell us that both of these shapes are rectangles. Very important, because if you notice, they don't give us anything about the angles. But because we know they're rectangles, I know that the angles all have to be 90 degrees. So the ones that correspond go with the letters that they gave us. Angle A is congruent to angle E. Angle B is congruent to angle F. Angle C is congruent to angle G. And finally, D is congruent to H. And this is because they're rectangles. They're all 90 degrees. So then the next thing we have to do is we have to match up the sides. So again, remember, because this is a rectangle, I know that this side and this side have to be congruent. And the same thing with these. And the same thing over here. This and this and this and this. So I want the corresponding sides to be proportional. So that means AB over EF should give me the same thing as GH as CD over GH. So AB and CD both have to be 6, and EF and GH have to be 4. And then we got to do it with the other ones. BC over FG should be the same as AD over EH. And BC and AD are both 9, and FG and EH are both 6. So if we simplify this one, we get 3/2, and if we simplify this one, we get 3/2. So we get the same thing. Because these are proportional, this means that these two rectangles are similar. And our similarity statement can say that we have rectangle ABC is similar to rectangle EFGH. So let's do another one. Determine whether the polygons are similar. If so, write the similarity ratio and the similarity statement. So we have these two triangles here. And the first thing I'm going to look at is the angles. So right here, I know that this side is congruent to this side, which tells me a lot about these two angles. Remember, these two angles have to be congruent. So if we've already used 36 degrees out of our 180 up, that means we have 144 degrees to split evenly between P and R. So if we cut that in half, we end up with both of these have to be 72 degrees. And you can quickly see that that doesn't match up with the other one, but if you want a little more proof, again, these two side lengths are congruent, which means this angle has to equal this one. And if we use up this 124, that means that this up here is 56. So already I know, without doing anything with the sides, that these two are not similar. Let's do another one. We got triangles again. So they tell us that we have a right angle, so we know that angle M and angle N are congruent. They tell us the angle L and angle P are congruent. And then remember, third angle theorem talks about these two. Angle J has to be congruent to angle S. So now we have to talk about the sides. And remember, we want corresponding sides to be equal. So the side in between the two angles that are not the 90 degrees is 75 over 30. The sides that are in between the one angle and the right angle is 60 over 24. And then the sides that are in between the right angle and the two angle tick mark are 45 over 18. So be very careful when you're dividing these. We want the ones that correspond to line up. So 75 divided by 30, 15 goes into both of them. 15 goes into 75 twice and into 5 times and into 30 twice. 60 divided by 24, we end up 12 going into both of these. 12 goes into 65 times and into 24 twice. And then 45, 9 goes into both of these. And because all of these are the same, that means that these have to be similar. So when we write our similarity statement, we have to say them in the correct order. So let's say triangle MLJ is similar to triangle, start at the right angle, so N, and then I went to the one angle mark and then the two angle mark. And then the last thing, this is applying what we know about ratios. So this is kind of what we did yesterday. A boxcar has the dimensions shown. The model of the boxcar is 1.25 inches wide. Find the length to the nearest inch. So we're going to set up a ratio and then turn it into a proportion. So the regular boxcar is 9 by 36.25. That matches up with the model by 1.25, has to be the same as x. And then remember, we can find our cross products. So we get 9x equals 36.25 times 1.25, which is 45.3125. And if we divide both sides by 9, we end up with this x being 5.03472, repeating forever. But because this says find it to the nearest inch, we're going to say about 5 inches. So you should be able to identify similar polygons and then apply those properties to solve problems. Make sure you write down any questions you have, and we can go over them in class tomorrow. Have a good night.